Hello everyone, my name is Vinita Sukla. This project is the part of our course Deep Learning and its Application. The course code is CS671. Our project topic is Adversarial Attack on Image Classification Model. This project has been guided by Dr. Aditya Nigam sir and mentored by Ms. Roma. Our group members is Vaibhav Sharma, Ankit Sharma and Series V. We have implemented this paper, Attack to Fool and Explain Deep Networks by Navid Akhtar. So, adversarial examples are carefully manipulated inputs that appear natural to human but cause deep model to misbehave. The tiger cat images is predicted as a tabby class. The adversarial noise is the tiny perturbation which are imperceptible to human eyes. Adversarial attacks involve the manipulation or exploitation of deep learning models. In targeted attack, labels of the attackers have the choice. There are two types of attack, white box attack and black box attack. In white box attack, attackers has complete knowledge of model parameters and gradients. In black box attack, attackers do not have any knowledge. For the given input X and model F, can we predict the gradient? Can we compute the gradient? Yes, for the white box model we are able to compute the gradient, and for the black box model we are not able to compute. This is the loss function. We are using L2 norm and L infinity norm to attack the classification model using white box techniques. This is our problem statement: to understand the role of gradient in white box, to replace the gradient computation in such way that method becomes black box. In this methodology, we are doing the stochastically maximizing the prediction probability of an image distribution part of samples for a given target data. Maximization takes place by iteratively stepping in the expected gradient direction of the classifier loss surface with respect to input samples. The problem formulation: for the given input, we are taking the data of the real distribution, the classifier K of input image. We are generating the perturbation on the real distribution. The optimization of this problem: we are adding the perturbation on the input image, and there is mainly three constraints we are following in this paper. Let's suppose we are having the example of kangaroo class, and our classifier is able to classify into the German Shepherd. The second scenario is ostrich class, and classifier is predicting as an ostrich. This is the expectation in this algorithm. This is the main important part. We are averaging this all the loss using the expectation maximization. Let's see with the example. We are having the source samples and non-source samples of the images. We are adding the perturbation. We are getting the perturb source samples and perturb non-source samples images, and we are feeding it into the model, and model is giving the loss and loss with respect to source samples, and this loss with respect to non-source samples. Then we are doing the back propagation. After back propagation, we are getting the gradient of expected gradients. We are averaging it, and we are getting the updated perturbation. We are implementing the merger VGGNet, AlexNet and VIT ResNet. We are taking ImageNet data consisting of 10 classes. Here we are seeing the loss with respect to non-source sample and with respect to source samples for the attacking model. Here is the loss computation for the model explanation with respect to source non-source classes. These are the result we are getting for the ResNet 18 model. The cassette players is perturbation. After adding perturbation, it's getting the result snow leopard. This is the result on VIT model, bear class into the Springer, and this is the result on the AlexNet model. This result is showing on the VGG16. The feature of target class as a perturbation, we can see that after on the 100th iteration of the VIT model, the Indian cobra is really seems to be visible. If you zoom this image, you will be able to see. So, and this is the castle on 64th iteration of ResNet 50 model on VGG16. The hummingbird, this is the 87th iteration. So perturbation refinement is also one of the most important process in this algorithm. Basically we'll try to implement the information. We can get the very good feature if we are having the more samples of the images. Thank you everyone. Project future direction is implementing it using the black box techniques. Our project